Welcome, everyone. My name is Mark Hughes, and I'm part of the team at Advanced Assembly and Royal Circuit Solutions that are located in beautiful Hollister, California, and Aurora, Colorado. We thank you for joining us today for this presentation on panelization. For your convenience, this webinar is being recorded and will be available within 2 business days at either royalcircuits.com/blog or aapcb/blog. If you have questions, you can either direct them to me directly at mhughes@aapcb.com or either of our sales teams at sales@royalcircuits.com or sales@aapcb.com. Those are a little easier to remember and they get routed in the right direction anyway. With that, let's go and get started with our webinar on panelization, brought to you this week by Advanced Assembly and Royal Circuit Solutions. If you have questions as we proceed through this webinar, you can ask them in the Q&A box down at the bottom of your screen. Please ask them there, as we will not be monitoring the chat screen for questions. Let's get to know our first presenter, Elijah Gracia of Royal Circuit Solutions in Hollister, California. Elijah is one of my favorite CAD/CAM engineers at Royal Circuits. Great guy to get to know. If you have questions and you need them answered about your next design, you can either email sales or Elijah directly. Elijah, tell us a little bit about yourself.
Hey everybody, as Mark said, I'm Elijah Gracia, and I've been working here at Royal Circuits for about 6 years now on the engineering team. I'm one of the first steps to see your design and help kind of get it spell checked and ready to go on the production floor.
And Elijah, how did you find yourself to this particular line of work?
The job was available. No, I'm just kidding. I always had an interest in circuit boards, mainly from my personal experience with guitar effects and stuff like that. And so Royal Circuits was a pretty cool connection.
Very cool. Wait, guitar effects?
Yeah, I play the guitar, and guitar effect pedals use circuit boards, and it's a pretty common do-it-yourself type of thing. So that's how I started.
Wow, you know, you wouldn't believe the number of people that are musicians and engineers at the same time. That's pretty interesting.
Oh.
Ben Jordan over at Altium. I've been known to, I don't want to say I play the guitar. That's far too generous an example or a description of what I do. But hey, man, next time I see you, we'll have to pull out some guitars and make some noise.
Absolutely.
All right, buddy. So let's get started with panelization. We've split this into 2 sections, fabrication and assembly. Unfortunately, our assembly house partner was unable to join us today, so I'll be filling in and representing Advanced Assembly for that. I don't have all the answers, but I've got enough of them that hopefully you'll find the presentation useful. All right, buddy. So, I mean, the first thing we want to know, I mean, if I'm ordering, how many things can I fit onto a board? How big are our panels? I mean, how does this all work, Elijah?
Yeah, so we have a standard panel size of 18 by 24, and that's the bare material. We use the outside 1-inch border all the way around, and that's for our registration coupons, for our mounting holes, everything that we're going to need to register your board while we're making it and actually pin your board down to the machines. So your usable space is going to be 16 inches by 22 inches. You can fill that in however you want. And today we're talking about panels, or also known as arrays. And let's see how you can best fit those.
All right. Well, hey, man, let's find out. So if I'm putting a bunch of boards together, I guess let's talk about the process real quick. At what point do they get separated out? At what point in the whole process, do they start to look like individual boards?
Yeah, so that's going to be after assembly. Usually these are put into arrays to help and aid with the assembly process when you're doing pick and place machines, stuff like that. And after the parts have been put on, that's when they're going to get popped out and you'll start to actually see your single individual boards.
But they get, you know, the route outs or the V-scores, all that happens before shipping, right? Before it goes to assembly?
Correct, yes. One of the very last steps when we cut the actual array out of the panel, we're adding in the V-score, we're adding in the mouse bites, all those last steps.
Okay, you're just trying to get it ready so that by the time assembly gets it, it's still sturdy enough to hold together, but weak enough that it can be broken apart.
Correct. That's exactly what we're trying to do.
Okay, so what's the difference between a V-score and a mouse bite, sir?
All right, so a V-score, we're actually taking basically a saw blade and hitting it from the top and the bottom at a specific depth. And what it's doing is leaving just a tiny little piece of material left where it can actually crack. The best example we use for that is like a graham cracker, how it has those lines on the top and the bottom that kind of leave a little bit of the graham cracker left, just enough for you to crack it. That's exactly what V-score is with circuit boards.
How interesting. What about mouse bites?
Mouse bites, that's when we leave a little tab left on the material all the way through. And what we do is we actually drill 5 little holes pretty close to each other so that with enough pressure applied, it just kind of cracks those little gaps.
So is that like saltines then?
Exactly. Wow, I didn't even think of that. Saltines do have those little holes, right?
Hey, that's what the edges look like to me. I mean, it looks like they probably, made an array of saltines. I don't know. They could
Right.
they could press those out individually like Doritos for all I know. I mean, who knows? All right. So let's take a little bit of a deeper look at V-scores.
Okay, so I guess the rule of thumb here is when we V-score, we're going to cut about a third of the board on the top and the bottom, leaving about a third of the material in the middle. So that depth all changes based on how thick your board is. The other thing we can do sometimes is customers might have an odd shaped board where maybe the left side is a lot shorter than the right side. So we have to be very careful, and we can't score all the way across. Like you see on the right side, these are all long lines where we can just take the blade and go all the way across, no problem, up and down, left and right. But maybe your board, kind of like the image on the bottom left, it has these little pieces where, maybe there's a circuit board sitting right above that cut. So we have to be very careful. That's going to be called a jump score. That's where we're only cutting small portions out, not your whole entire board. And that all goes on your design. But that's another feature that we're capable of.
So without without these jump scores or skip scores, whatever they're called, this board would have the tendency to bend or warp, right? So these things also look like they provide quite a bit of rigidity.
Yes, exactly.
So if I was over at the assembly side, I would break off the top piece, break off the bottom piece, break off the 2 side pieces, and these things could, just start falling apart. Well, I mean, as much as they fall apart.
Yeah, with enough pressure, they can definitely fall apart. Like you said, like the rails help a lot. This is all helping it stay together as long as we can keep it together.
What are these? Are these tooling holes? These little green things that I see that you put on your picture here?
Those are actually fiducials. What a fiducial is kind of a registration mark. So when you put it on the pick and place machine, it's going to read that and know exactly what your coordinates are. It's going to know exactly where to place each part on each individual board.
Interesting. All right. All right. So if I'm putting mouse bites, if I'm designing mouse bites into my my project, can you tell me a little bit more about where I want them, why I want them, where they go? I mean, all that.
Yeah, definitely. So if you're doing it on your side, what our general rule is keeping them 5 mils inside of your actual PCB outline. And the reason for that is when you're breaking it apart, if you look at the very bottom example, what's going to happen is you're going to have that little probably 1/8 of an inch, 1/4 of an inch piece of circuit board popping out. And that's going to snag on everything it can. It's going to cut your fingers because you're going to have raw materials sticking out. So it's a little harder to work with.
Yeah, and doesn't that violate the inspection standard, the J standard for boards?
Yes, correct.
Or whatever it is. Okay, so it has to be clean. All right, so I did a little graphic here for you from Royal's specifications. Can you tell me a little bit more about what you guys recommend and what all these little numbers mean?
Definitely. So let's start with those 5 holes you're seeing right up top. Those are going to be 5 20 mil non-plated holes, and you don't want plating in there. That's just going to make it harder to break apart. There's no purpose for it. So there's going to be 20 mil non-plated holes. They're going to be about 30 mils apart from center to center. And then, like we mentioned before, they're going to be about 5 mils inside of your board outline. So they're just going to be popping over just about 5 mils. That's going to get you that clean cut. when you're finished. The other thing is our standard route size, because we are routing your board out and leaving a tab, a solid piece of material. We're going to use a 70 mil router bit. And the gap you're going to leave for those mouse bites is going to be 150, and that's from route edge to route edge. So
Okay. Now, how frequently do you want these things spaced, these mouse bite connectors?
1 every 2 inches is perfect. That's going to make it easy enough to break apart and not too much where we're struggling to get these to pop out.
Yeah, and I guess if you put them too far apart, you worry that the board's going to depanelize during shipping to the assembly house, right?
Exactly. Yeah. Some of these heavier, thicker boards, they can start coming apart during shipping.
Interesting. Okay. What about board thickness? Does that affect how you make these?
Yeah, definitely. So we can go as thin as 20 mils. Anything thinner than that, and your board is basically going to be tearing apart instead of breaking. Just that's way too thin of a board. They're going to have to be routed out individually, and if it gets anything lower than about a 15, they'll probably be laser routed anyways. So that's just not going to work. And on the other end of that, anything thicker than 125 mils, it's just not going to work out. You're going to be still trying to break through about 1/8 of an inch of material, solid material, and it's not going to go well. You're probably going to get some DLAM from having to put so much stress on that board.
Interesting. All right. We'll make this graphic available on our blog page along with the webinar. So royalcircuits.com/blog. That's interesting. Do you know anything about how you design these into, say, like Altium Designer or something like that?
I don't have any experience with the Altium Designer.
Okay, that's okay. But you guys do that on, you guys do all of this on the Royal Circuit side, right? I can just tell you, here's my board, I want 20 of them, and you'll handle everything, correct?
That is our favorite way of making it happen.
Wait, you don't actually want designers to do this themselves?
They absolutely can. It's not a problem. We can follow their guidelines, but it does take a lot longer because we have to manually place everything, where we have software that automates all this. We just tell it where we want it, the center point, and boom, it adds everything you see right here, throws it all in for us. And it's super fast. It's very reliable. We've been doing it for years and years, and it's just so much faster.
Well, why don't we just do that then?
Sometimes customers ask for very specific dimensions on where they want their mouse bites or where they want their V-score to happen. And we're going to give them what they want, which is fine. It just does take a lot of time. I have to manually place each hole. I have to manually place each slot, and then still compare it with our rules and make sure it's going to work out.
Interesting. All right. All right. We've got a question regarding this diagram. The 5 mil offset, is that out from the center line spacing or in from the center line spacing? And it's outside. So if we were to draw a line at the board edge and we move 5 mils out from that, that's where our center hole centers are. So that means you're losing about 5 mils of material on the inside of your board edge. Your copper should be set back 15. So that still leaves you 10 mils of fudge factor room that these mouse bites are going to be separated from the nearest copper. So hopefully that answers that for you. Okay, here's a question, and I love it, Elijah. I love it.
All right.
You're going to love this one, man. Can we put copper between these mouse bites? Can I route traces, breakaway traces for programming or testing?
With 30 mil, that's about 10 mil spacing. I mean, technically you could. It'd be pointless in my side, but I mean, yeah, I mean, I'm guessing it's gonna break. I've never done it before, but you're gonna have some problems when you're breaking that. You can lift the trace up. And
oh, we don't want the trace to exist afterwards. This would be like when you've got everything in the panel and you want to do a little bit of functional testing, or let's say okay, so forget about it being a breakaway for a second. Let's just say I've got two halves of the same board, or two PCBs that are going to be connected temporarily, right? I want to program it, and then I want to break off the programming headers so somebody can't come through and, you know, hack my design
Right.
or that sort of thing. Would that be doable?
Okay, physically, yes, we can do that.
Okay, so yeah, no, we would want the traces to break. So to answer that question, yeah, we can do it. Good question. I had the same one. All right.
Yeah, that's no problem. We just use a special technique to get those non-plated holes very accurately placed.
Okay, or I guess you could increase the spacing a little, right?
We
Might be
could,
a little
yeah.
cleanup afterwards, but
Yeah, that's another thing. That's something we would kind of do as that problem came.
yeah, or talk to the designer about it. Okay.
Yeah.
So we've got a couple examples here. What are we looking at?
Yeah, so on that top left, this is an example of mouse bites. It's got those tiny little holes on each side. Each one of those little rectangular bars are going to be able to break out. These are actually pretty tight together, so I'm guessing this is a thin board where it still would pop out fairly easy. And then on the bottom side, it looks like we have a V-score. I'm trying to see it, but
Looks like
yeah,
we've got the V-score along the top and bottom. So it looks like it's a V-score and route example.
yeah, so it's been routed out for the most part. And then this one looks like it hasn't been scored yet. You would see a cut line, but yeah, it's just going to be held together with those top and bottom rails through the V-score method.
Interesting. I've got a question for you though. It says 0.1 inch spacing between boards, but on our last slide, we saw that we've got 71 mil minimum hole. Is there a reason for that discrepancy?
Yeah, so depending on the design of the board, the shape of the board, what's going to happen is we need some board still left to hold itself together.
Okay.
Yeah, to actually hold this route.
But okay, so I think what I'm asking though is the curve for that cutter is less than the spacing between these boards. Do you guys go up one side and down the other? Does that affect the cleanliness of the board edge?
Correct. Yes, we do go up one side, down the other.
Okay. And is that, do you know if that's conventional or climb milling by any chance? Or I'm just curious. It's okay if you don't know.
I'm not sure.
Okay, no worries.
But the reason we do that is the actual router bits that cut the board, they're meant to cut in one direction. So even though it is cutting on the other's opposite side, it's a pretty ugly break. So once it comes back around, you're getting the proper rotation for the cut.
Okay, all right. We've got a question, and I think it's just a clarification that we need to make, but it says, if you mill the boards out, is there any reason to use mouse bites?
If you're milling them out, no, there's honestly no reason to. It might help you, give you a guideline to where to cut. It might make it easier for you to cut also, but not necessarily necessary.
Going back one slide, and then we're going to move on. Is there any reason for this 5 mil? I mean, could I use a 10 mil offset or just leave it right on the edge? Is there a reason we use the 5 versus something else?
5 is just what's worked best in our experience. You could go 10 in. That's the max I would want to go, because then again, you're going to be breaking into the board more than you want to. You're risking delamination, splitting the layers of that board, splitting the dielectric in between the layers.
Got it. Okay, so that's just from empirically derived number. That's always good.
Yeah.
Okay, let's keep rolling, Elijah.
Sounds good.
All right, so what are some of the benefits of using a big panel instead of, you know, separating the boards before, you know, when you guys ship it off to the assembly house?
Yeah, perfect. So right away off the bat, it reduces cycle time. It's going to spend less time because we're not going to have to route out every board. We're going to have to route out parts of every board and then just pop out the array. That's no big deal at all. It reduces reflow oven time. Again, we're working with multiple boards at once. You're doing kind of the same way we build multiple boards on an entire panel. We're able to save a lot of time rather than building one PCB at a time. That would just be ridiculous, right? So same way. Stencil and solder application are quicker. Again, we're throwing up like in that last array we had in the beginning. There's 44 boards on the array. We're able to slap on 44 stencil and arrays at once. That's awesome. You must inform the assembly house to create panelized stencil. The fiducial placement, that's perfect. That's what we do on our side, unless you have your fiducial's, I guess, specs or coordinates given to us. But that's going to aid in the pick and place. And some assembly houses use paste printer or stencil and panelized design files not needed.
Okay, so I think I can cover that. So at Advanced Assembly, we've got a paste printer. So whether you give us a panel or whether you give us a single board, individualized board, it doesn't really make all that big a difference. But if you are going to go to an assembly house that uses stencils, if you've got a single board or you've got a whole array of them, you need two completely different stencils to handle that, right?
Yeah.
So I think that's what that one's getting to.
Okay, awesome. And the other part was it's got to fit in the assembly machines, right? So check with your assembly house and see what the biggest panel they can actually fit into their machines. That's also very important. It's got to fit in the pick and place and the reflow ovens. So right there, Advanced Assembly can accommodate up to a 20 by 24 array, which is more than we'd be able to create with that 24-inch gap. But hey, maybe whoever you are using is able to make something bigger.
Yeah, always good to know, right? I mean, Advanced Assembly, we can always get the board made somewhere else. I mean, no offense to Royal, we love Royal, but and we've got a great working relationship, and we often buy from Royal. But if somebody's making a server board or something, they need a few extra inches to hold all their components, we'll make it happen.
Yeah, definitely.
Okay, hey, I've got some questions for you though. Okay,
Sounds good.
So from a designer standpoint, so this is not speaking for Advanced Assembly, but speaking from a designer standpoint, I want to squeeze every last square millimeter out of that panel, right? Because when I'm buying boards, I'm paying for that whole panel whether I use it or not.
Correct.
So let's say a panel's 18 by 24 and I've got these little, playing card size boards.
Right.
Let's say I want 10 of them. Who pays for the rest of that panel?
Technically you pay for the panel, but the best thing to do is tell us what you need, and we're going to try to fit as many as we can in the best fit we can. That way we can get you the most for your money kind of thing.
So any unused board space I'm paying for anyway.
Correct.
Elijah, I don't like that.
Yeah, so, it's good to know, talk with your sales rep, let them know what you're able to fit on the panel and, get the most out of that.
Okay, so if I do have a small order, is there any chance that I can save money by can you guys merge my files with another customers? So we're splitting the panel, that type of thing?
We absolutely can. Your board does have to meet certain qualifications. Basically, we have very plain vanilla flavored boards with very standard specs. And if you fit in that, yeah, we can gain your job with some other customers.
Okay. All right. Well, let's keep rolling along. We do have some questions. I don't know if you're able to answer this, but do you know what software you use to do the panelization?
Yeah, we actually use Valor Genesis, kind of an older one, but it works amazingly. We have it very well scripted from our IT guys, and yeah, it's very fast to do the arrays on our side.
Okay. Do you happen to know if we have any rule files for Altium? Do you know what rule files we have available at our website that designers can import?
I don't know offhand. I can check with that and get back to anybody.
Okay, cool. All right. So for that gentleman, I know we have rule files at our site at royalcircuits.com. I believe it's under the resources tab. I don't know what EDA softwares are supported, but if we don't have Altium, we need them. I can ask about that and find out for you. All right, let's keep rolling along. So shipping, right? If we ship boards, let's say I've got an array and I've got, I've squeezed somehow 200 individual boards into that array. How would you ship those?
So obviously with anything, when you're shipping smaller boards, it's going to be easy for us to package and inexpensive. As they get larger, obviously I'm going to need a bigger box. I'm going to need more materials to pack that box, and shipping price from the supplier is going to go up. So um, it's always best, like we mentioned a few times, is just to let us decide on how this is best going to fit, because we're going to keep shipping in mind also. We have our standard specs that we like to follow to keep the boards small enough, or the panels small enough for shipping.
Okay, all right, let's keep rolling along. What about depanelization? When we start individualizing these boards, are there any concerns with mouse bites that you're aware of?
Yeah, so one common thing that is, if a customer's designing their own mouse bites, it's very common for them to put them too close together, which is very hard to pop out unless they have a depanelizer, a little machine that's going to pop those out. We'll always check with the customer though. If it goes within our, yeah, I guess if it breaks our personal rules, we're going to check with them and make sure they're going to have a way of cutting these out.
Okay. What about V-score?
V-score. The benefits of the V-score, it's got greater strength. They're actually very strong. It's kind of weird, even though it's very easy to pop out, they stay together if you're not messing with them. If you're not bending the boards, then hey, they're going to hold on just fine. It is a preferred method in the assembly houses, especially in advanced assembly. Some of the concerns are it needs a lot of force to break apart. That's really only true once you're getting into those thicker boards, or if you have a spec that's saying, hey, I only want 5 mils out of the top and the bottom cut. That's going to be really hard to break apart. But again, let us decide on all that stuff. We've been doing this a long time. We know how deep to V-score, and to leave you enough material where it's strong enough to stay together until you want it to break apart.
All right.
Copper traces also being too close to the score. We do have 10 to 15 mils of clearance that we want. So keep your copper away from that board edge anywhere there's going to be that score cut.
All right. So one thing I want to bring to people's attention is that 10 to 15 mil copper offset, bringing it back from the edge. If you've ever done any rework, you probably know how easy it is to peel copper up, right? It's got about this roughly the same adhesive force, or at least the same order of magnitude of adhesive force as tape. You know, your typical transparent tape you might have at your desk. It's that easy to peel. So if you keep the copper inside the board edge, you've got epoxy bonding to epoxy and fiberglass. It creates a stronger edge on your board than if you ran the copper out to the edge. So when you start popping these boards out of the panel, there's less chance of delam. It's also a less chance of short circuit, so keep the copper inside. Also, for your components, if you've got, a USB connector, RJ45 or something that you want to just bring, right up to the board edge, we can maybe make it happen. You can even maybe let one or two hang over. But if you have all of your components, especially your small things, your little passives, I can't think of, the O201s, that sort of thing. If you keep those right up to the board edge, they can actually pop off during depanelization. The stresses can be just too great from that. So about 10 to 15. Elijah, do you guys plate castellated holes when you're making these boards?
We do plate castellated holes.
All right. Somebody asked what the price is, and we're really not the guys to ask for that. You need to email sales directly, sales@royalcircuits.com. We really have no idea.
Yeah, they can get that for you pretty quick.
Okay. So going back to components on edges, it is okay to run some components right up to the edge. You can't run small components up to the edge. You can't run all components up to the edge. Keep them back 10 to 15. Otherwise, like I said, when we break these things off, we can pop your components off too. And then you'll be sad and you'll be mad at us and it'll just be thought good. Tell us a little bit about gold finger design, Elijah.
Yeah, so gold tips, a lot of customers don't know this, but you really got to keep in mind if your board has gold tips, you got to keep the tips to the outside edge. That's the only way we can bevel them. If you point them in towards the inside and somehow we don't catch it, it's a pretty big problem because we can't fit the bevel machine in the inside. It's made to bevel an edge, not an inside cut. So again, gold tips, keep those on the outside like you see in that image.
Interesting. I never would have thought of that. So if I have a bunch of these that need to be made and the gold tips have to be on the outside, will you make a smaller array or how does that work? Would there just be a bunch of dead space right down the middle?
We're going to try our best to make it work like you see ahead. Basically, it can only be 2 pieces wide because you need a gold tip on each outside edge. But give us your design. Let us know what you need or what you're trying to do. And we can even go more boards up. Like you see, you can't see how far this board goes, but you see 4 pieces. It can go 6, 10, 12 pieces long. So there's still ways of making your specs count.
Interesting. All right. All right, so we've got a couple of pictures of some depanelization machines. Are you familiar with these, or does this mostly just happen at the assembly house?
This happens at the assembly side. We don't actually depanelize. If a customer decides last minute that they don't want their boards in an array anymore, we actually just cut them out with a router.
Oh, okay. All right, so it looks like we've just got a score blade that probably just applies some amount of pressure. Another reason to keep your parts from going to the very end. And then this looks like a version of a punch press to me. So it probably just goes around and just targets those mouse bites and applies some downward force. So yet another reason to keep your components back a little bit. All right, so you've got to communicate with your fab house. Whatever it is that you're going to do, talk early on. If it was me as a designer, right, I have never made my own panel. I just say, hey, I want 20 boards, and I let somebody else worry about all of this nonsense because it can get a little crazy and it can become a little confusing. What about you, Elijah? What would you recommend?
Yeah, it's definitely all about communication. What you want to do is tell your board shop, here's how I'm sending them. Here's how I want the assembly side to receive them. And here's how I would like my boards to be shipped when I get them. Technically, there's not a lot of reason for you to need the array. So, you know, maybe you just want them one up, cut out individually.
Okay. All right, with that, let's start tackling some questions. You up for it, buddy?
Yeah, let's do it.
Okay, I've got one that's a little off topic, but let's hit it up. What's the charge for like a matte black solder mask? Is that, do we charge more for that? What do we do over at Royal?
Same price as any other one. Royal Circuits is one of the very few shops that will offer you any color with no price change.
That's right. Don't we have some sort of a pigment printer or something like that?
We do. We can basically get you any color other than a metallic finish. If you're looking for that, we can't help you out there. But any other color, we can absolutely do it. We have a few customers that have very custom color codes that they request, and we work with them, get that down, and they have their own color code that we can mix for them.
Yeah, there's actually a very popular board, let's call it a broker, that has a specific color that they use to market their boards for. And they recently offered a matte black, you know, within the last couple of years. All of that actually gets made over at Royal because we don't upcharge for that. So if you do have a board house that's charging you for that, they're just taking you for a little ride because they can. It doesn't cost us any more to put red on than it does to put green. So if you want red, green, blue, purple, yellow, whatever, we don't really care. We do it for you, no upcharge. So just a little value add. We've got quite a few questions regarding castellation. The first one is, what is castellation? So what's a castellated hole, Elijah?
So a castellated hole is actually, best way to put it is it's a hole right on your board edge. So it looks like half of a hole. And they're generally plated. So what it's doing is that, let's say you have 5 of them next to each other, that's probably sliding right into a component. So your component's essentially functioning with the board edge that's plated.
And what that does is it provides increased surface area for soldering later on. If you've ever added a Bluetooth module to your project, those often have castellated edges. And again, it just gives an increased surface area for the solder fillet to form, a little stronger mechanically. Can we fill castellations? Can we gold plate them? What can we do?
You can definitely gold plate them. That's no problem. You can finish them any way you want to. You can't fill them because it's half of a hole. So there's a lot of problems of that. I'm trying to think. It's never been requested, but I guess if you don't cut it out first, you might actually be able to fill it and then route it, but that'd be kind of weird. I'm going to look into that. That's interesting.
I don't know why you would. I don't know
I don't know why you would either, because you want the shape for your component, and if you fill it, you can no longer put anything in there.
It might as well be like a gold finger, a wrapped gold finger at that point.
Yeah, that's
interesting. I don't know. If you know why you might do that, I mean, let us know. That would be an interesting problem. Do we do that with Enig or AnyPig? Do you know?
Generally, Enig, it's a very clean, smooth finish. I have seen it done in Hassel. It's kind of sloppy. Hassel is very uneven, but yeah, standard would be gold.
Okay. Question is there increased cost during assembly for rotating PCB in a panel to meet the gold fingers on the outside requirement? Not really. You would just have a different XYRS file for that particular board. It shouldn't really be anything more than a regular panel. I can't imagine why it would be an increased cost. For a simple rotation, there should be zero. Maybe if you, for some reason, flipped that board, we might have to reload our, no, even then, I can't really think of a reason why we would charge an increased cost for the other part of the panel, the rotated parts. So I'm gonna say no. I could be wrong, but I don't think I am. Okay, do we wrap gold fingers? Can we do that?
What do you mean by wrap?
So you want the gold finger to wrap onto the edge and wrap over to the other side.
That's a good question. I haven't seen it, but from the production side, I'd imagine we could, just the same way as a plated edge.
Yeah.
Yeah, I don't see why that would be a problem.
Yeah. But the other thing that you can do, anonymous attendee, is maybe do some via stitching. Some micro vias, just connect those two planes electrically instead of trying to run the edge. I could see some reliability issues appearing over that.
Yeah, I'm thinking as you're inserting those edges, you might get some breakage, depending on, especially because they're so thin.
Yeah, or as the board heats up, something like that. Yeah. I don't know. You might want to stitch it with vias instead. It just depends. Okay. Can we have more than one silkscreen color? Absolutely. We would just, like you said, apply the silkscreen process twice. But it's not just putting the silkscreen on. You got to put the silkscreen on, then you got to take it to the micro steam oven. Bring it back out, put the silkscreen on, take it back to the micro steam oven. Totally doable, but you're adding processes, so you would expect a increased price. How much? I don't know. That's a question for sales.
Correct. Yeah, we do. I think the most I've seen was 5 colors of legend thrown on at once.
Really? Are they doing artwork, or what are they doing there?
I can't remember the company name, but basically it was a do-it-yourself type of thing, and they color-coded everything for you.
Oh, cool. Okay, yeah, that's kind of cool. I've often thought it would be cool from a graphic art standpoint to do that, and I know we've done logos where the company wants their branding to be specific to their board before they hide it in a plastic box, never to be seen by human eyes again. But it's nice.
You're right. That's exactly what happens to the circuit boards.
Oh well. Okay. So we've got several more questions. How much horizontal distance is needed for deburring after the 30-degree V-cut? Okay, so this is back to our board edge question, and I think we're asking 15 mils preferred. What's our bare minimum?
Yeah, bare minimum would be 10 mils. And again, we're hoping that's a copper plane rather than a trace because the trace can lift up.
Okay. Is 30-degree V-cut the only option?
Yes and no.
Okay.
It's going to be a lot easier, I guess, standard scoring. Yes, it's going to be 30 degrees. That's going to be the cut size. It does get deeper as your board gets thicker. Let's say if you have a 125 mil thick board, obviously we're going to have to cut that out with an actual router. We have special router bits that kind of create that same shape, and that's where we can change the degree of your cut.
Okay, what if I've got I'm trying to panelize and I want to rotate a couple boards, 90 degrees, just so I fit more boards per panel. Is that a problem for you guys?
For us on our side, no. As long as it's still getting that same V-score on all edges, yeah, that's no problem at all.
Okay, and then the question is, what do we do with leftover board material? Once it's processed, it's done. It goes in the garbage. You can't make a new board out of it because boards are made like sandwiches, as I've heard Elijah use an analogy before. And, it's like cutting the crust off. Okay, what do you do with the rest of it? You got to throw it in the trash. You can't save it for the next sandwich, so.
Correct.
Questions that we're getting several of either over here is, what's the maximum panel size? I don't know if you guys saw that, but advanced assembly, it looks like we can throw 20 by 24 into the reflow and into the pick and place. The problem comes with the jet paste printers that we love jet paste printers, but you can't put something that wide into the jet paste printer. It doesn't feed through the pass-through slot. I think they might be able to open the sides of the machine and put it in that way, but more than likely they would have to order a stencil for you. It's no big deal. I mean, people make boards with stencils all the time, and that's how production runs, but that might add a day onto your delivery time. So I hope that answers your question. We would not probably be able to put the full size board we can process through our pick and place. I don't have those specs on hand. We would need our process engineer who's not here for that one. So, but if it needs to get done, we can get it done. Just contact sales, tell them what you're making. They'll make it happen. Stencil, paste printer, even if we have to contract, we'll get it done for you. Okay. What are our space and trace minimums without cost adding? I mean, what's our preferred trace and space?
We do have a chart on our website for each copper weight, but standard, if you're talking about like a 1/2 ounce copper, we're going to go 3 and 3. If you can stay at that, we're going to be happy.
Okay. What about minimum via sizes?
Absolute smallest size we can do is 5.9.
What about without, is there any charge for that over other via sizes, or is that just standard?
That's our standard minimum. Anything smaller than that would probably have to be laser drilled, and that's where you're going to get the cost adders.
So that particular gentleman was asking for, would we charge more for 68 and 90 mil holes?
No, not necessarily.
Do we drill those, or do we do like a helical bore? How do you get 90s?
90s are drilled. Anything
Okay.
up to 255 mils, we drill.
Okay, and then after that, we do like a helical bore or something like that?
Yeah, we'll actually cut it out with a router.
Okay. All right, so hopefully that answers it. So down to 5.9 mil finished. Oh, thickness. He was asking for thicknesses. That makes more sense. The aspect ratio limitation comes into play, Davey. So you don't really want to get more than, say, like a 10-to-1. We can. We certainly go 12, probably up to, how high would you say for our aspect ratio, Elijah?
Yeah, I think 12 is peaking out. Well, I mean, there are other options. If you have a very thick board and a very small hole, what we can do, which does cost more money, is you kind of build it up in layers. We're going to build the middle of your sandwich and drill through it, add the next portion, drill through the smaller portions that were added, so on and so forth. It's one way to get there, but it does add quite a bit of money because you're adding a lot of processes.
Yeah, so stick to the 10 to 1. You know, if you've got a 90 mil thickness, you know, you want a 9 mil drill, right, Elijah?
Correct.
Okay, so hopefully that helps. So while we can drill down to 5.9 mils or do a 5.9 finished hole, you would only want a 59 mil thick board for that one. All right. Some of these questions aren't quite filled out and I don't quite understand them, so I don't mean to ignore you. I just don't really know what the question is, so we can't approach to answer it. We don't, people asking how much does it cost to do this, this, and this, and this, we are the wrong guys to answer that. We just simply don't know. You'll have to contact sales. So sales at aapcb.com or sales at royalcircuits.com. We just don't know. Okay. What's the max size board that can be made? So if we don't talk about Royal or advanced assembly, what's the biggest boards that can be made? Are those the 18 by 36 inch panels, Elijah?
That's the biggest panel that I've ever heard of, yes.
That's the biggest one I've ever heard of too. So if 18 by 24, which is pretty standard for most stateside fab houses, isn't big enough for you and you want to move to the more industrial ones, it can be done. I don't want to know how much they cost though. Okay, component orientation and spacing from edge. So for MLCCs, I would still say 15 or greater for your caps. They can break away from the board under the stresses. So if you can keep those away from the board edge as possible, the stress starts to spread. You know, from these mouse bites or wherever the V-score blade is, it spreads out as you move inward. So the further inward you are, the less stress it'll see during depanelization. So the other thing you can do too, if you are going to have, you know, you really need to get these things up to the edge, places like Advanced Assembly will deal with the small boards, you know, something the size of a, you know, let's call it a $50 coin. It's really no problem. Our machine vision will orient the board for us and, you know, adjust the XYRS appropriately. So if you really do have to get something up to the edge, we can do it. We just need to depanelize it before we assemble it. It's doable, and I don't know that it would cost that much more. I don't really know. Okay. Elijah, I don't know if we can answer this. What's the thinnest board for USB-C socket? So if we're putting a USB, what's the thinnest board you want to put on?
That one I would not know. Not too familiar with the assembly side.
Okay, so what are our standard board sizes?
Standard board sizes would be 031, 062, 093, and then I think 125.
I mean, you could do it on an 031, but man, that thing's gonna flex. I don't know. I don't know that. I don't know the answer for that, Davey. And you might even actually need to do some FEA analysis to find that out, or just some empirical testing. Okay. Do we know anything about the mechanical stresses for each depanelization method?
I don't, unfortunately.
Yeah, I don't know either. Obviously, if you're doing the mouse bite method, the stress is going to be concentrated in specific areas. So you could work around that if you're doing your own panelization, or even just put some silk screen images for where you want those mouse bites to go. That might be able to help you out with that. It might not. I don't know.
Yeah, using our standard specs and just letting us do it, it's pretty easy to pop them out. We do it all the time.
Okay. I'm going to put this to you, and maybe you understand this one. I don't right off the top of my head, but it simply states, unused portion on the panel needs extra copper to provide structural support to prevent warp.
Correct. What that's saying is, I believe it's saying, is the rails on the edge that are going to get popped off and thrown out. Those do get copper on the layers, on all layers. The inside are going to kind of have like a thieving type copper pad, and then the outside are going to have solid copper. And that's keeping the structure tight.
Okay. Okay, we were informed of what the filled castellations are for. So if you're doing wire bonding to the edge of the board, so if you're bonding out a die package and you need something to put those things on and then attach to something else for testing. Good to know. Okay.
Wow.
What is the weirdest material that you've made a board from?
Let's see, the weirdest material. Offhand, I can't think of one. I know we've used some weird stuff before.
Do you like
I
carbon
have.
fiber or?
We don't really use carbon fiber. I have heard of people attempting to use glass, which is pretty
Like
interesting.
Glass, just glass.
Yeah, like clear glass.
Interesting.
Yeah, I'd really like to look more into that one.
Do you know what they were making?
No clue. It was just kind of a little news article we seen that that was spread around.
Interesting. Okay, somebody asked, glass layers are used on ceramic boards. Okay, well, there we go. Now we know. All of this fun stuff with all of these exotic materials that I just don't get to play with. I tell you, life's rough. Life's rough. Okay, we did have one question that I will answer, and then we're going to end this webinar and let you know about next week's. Wanted to know what our router sizes are. So we've got this graphic that we will post along with the webinar. Can you tell us a little bit about it, Elijah, about our router curves?
So these are the standard sizes that we use for the router bits. 31 mil, 39 mil, 50, 62, 70, and 94. And each one we use for specific cutouts. If your board has a tiny little cutout or a slot that isn't going to work with a drill, we're going to use a router. And it also applies to that thickness we were talking about. Same with a drill. We can't cut a 125 mil thick board with a 30 mil router bit. It's just not going to work. We're going to be breaking bits every couple minutes and constantly replacing them. And we're going to start losing money at some point. So yeah, these are the standard sizes that we do use. So if you do have cutouts or slots or you're designing your own array, keep these in mind that these are our standards.
All right, and then somewhere down around 50 mils, you start getting those lateral stresses breaking bits pretty frequently, it looks like. So
correct, yeah, that's what that color code is going to be.
Okay. The tolerance of those router bits is going to be measured in the tenths or better. You do start getting wear after that, so it doesn't make sense to route them. But remember, you're not necessarily, if you've got, say, a 50 mil cutter, you are not going to want to route a 50 mil hole with that. You're going to want to route a 60 or a 75 mil. You're going to want the router to go up one side and come down the other so that you get a nice clean cut. Because as this thing makes the first plunge into the board, one side of it you're getting a clean cut and one side you're getting a rough cut because the feeds and speeds are wrong. So even if these are the minimum diameter curves that you can get, they're not going to be clean cuts.
Yeah,
so
the blades face a specific way, and that's why you have to go both directions.
But as far as the tolerance of the holes that we can get, definitely to the 1,000th, I would say, well, let's call it 3,000ths to be, just to be politically correct. But in reality, it's going to be much better than that. So with that, I want to again thank Elijah Gracia for coming in for this. It's always a pleasure talking with you, Elijah. Our next webinar is going to be on high speed, and we're talking very high speed. Yeah, of course, we're not getting into the terahertz gap, but man, we're going to come close. And we're going to talk with a representative from Panasonic Materials about really, really, really high speed stuff. So next week at 11 Pacific. If you have questions that you'd like followed up on, you can always email me. I'm mhughes at aapcb.com. That's mhughes at aapcb.com. Or just reach out to sales. We're not high pressure salespeople. That's not how we operate. If you have questions, about assembly, send them to sales@aapcb.com, and we'll get them directed to the right place. If you have questions about fabrication, email sales@royalcircuits.com, and we'll get those sent to the right place. Elijah, any parting comments?
No, thank you for having me. It's an awesome pleasure.
No, man, the pleasure's all ours. Thank you for, again, taking time out of your very, very busy day. And I hope that you have a wonderful rest of the day. Thanks, everyone. And we hope to see you next week on our Tech Teach Talk Thursdays. Take care.